Hey class, welcome back to the lesson on the surface area of pyramids and cones. This is the second video about finding surface area, and in the last video we talked about the difference between pyramids and prisms, and what we'll do in this video is talk about the difference between cones and cylinders. So if you've not seen the previous videos about surface area of cylinders, you probably want to go do that. So pause now and go check that out, and then come back to this one. Because here we're going to talk about cones. So you got to figure out what is a cone, right? So the cone is, this shape, like cone, like an ice cream cone. All right, so we have a three-dimensional figure. And when we talk about nets, we have talked about nets in the past, and what I think is interesting about a cone is the net of a cone. So check out the net of the cone. And we won't be using nets because at least in my class, we haven't talked about finding the area of what is this. This is called a sector, and we got to know what the net of a cone is made of because it's so kind of cool. If you want to build a cone, right, you get yourself a circle, and then get yourself a sector of another circle, where the arc length of that sector is equal to the perimeter or circumference of the circle. So the net of a cone is made up of a sector and a circle. You wrap it all together, you have your three-dimensional thing, and there you go. So remember the two-dimensional is the net from the three-dimensional figure. Anyway, so we have our formulas for lateral area and surface area of a cone, and they look pretty intimidating. Okay, so look at this. It's half the product of the circumference of the base and the slant height of the cone. And if you recall in the last lesson, what we had learned is that key ingredient called the slant height, that lowercase cursive L. So the key ingredient of working with pyramids and lateral area is that slant height. And in a cone, slant height is also equally just as critical, equally as important. But because we're dealing with circles, our formulas may make things look more challenging than they actually are. I'm telling you, it's the same as the formula for a pyramid. Okay, it's 1/2 the perimeter of the base times the slant height. So it's the same thing, right? So let's do some comparisons, right? Our similarities and difference between a cone and a cylinder. It's very similar to the similarity and differences between the prism and the pyramid. So we understand what's happening with the cylinder. Remember, we still have slant height. It's the same as what we worked with in pyramids. And we still have our altitude, right, from the vertex of the cone down to the center of the base. And, of course, we have our base, right? So this is the makeup of the cone. The formulas are very similar. So check this out. When we had our, this looks a little bit crazier than it should be. When we had our cylinder, if you remember, it had a crazy-looking formula where the lateral area was the perimeter of the base times the height. And the perimeter of the base was the circumference of the circle. Okay, so you remember perimeter and circumference are the same thing for a circle. So the perimeter is circumference. Okay, so that's an important thing to know. And so we're talking about in our cylinder, the base being a circle, the perimeter is either 2 pi times the radius or pi times the diameter. Okay, so either one, it doesn't matter if you could work with one to get to the other, it doesn't really matter, but the perimeter of the base times the height was cylinder. For a cone now, right, so now what we're doing is moving into the cone, it's half that. But instead of perimeter of the base times the height, it's perimeter of the base times the slant height. So it's half the perimeter of the base times the slant height now. That is our formula for the lateral area of a cone. Basically, how we're finding this, right? That's our sector area. 1/2 the perimeter of the base times the slant height. Now, in the case of the sector, the slant height is actually the radius of the circle that makes up that sector, but we're not going to dig into that. We're going to focus on this. So it's 1/2 the perimeter of the base times the slant height, but again, perimeter is circumference, so circumference is either 2 pi r or pi times diameter. Now, in the case of 2 pi r, this formula becomes interesting because we have a half of 2, which is 1, so it just cancels. So in the case of the lateral area, when we're dealing with 2 pi the radius, it turns out to be pi times radius times the slant height. But look, this is all just neat trickery. Everything else is the same. I want you to understand that it's the same formula. It's lateral area, 1/2 perimeter of the base times the slant height. So let's try and keep stuff as similar as we can. That way our brains don't get all mushy and overloaded, not knowing what is going on. Now, surface area is very similar as well. Remember, surface area of a cylinder, lateral area plus 2 times the area of the base. Surface area of a cone, lateral area plus 1 times the area of the base. Okay, so these formulas can look crazy, but I want you to see the similarities of all the other things that are there so you don't get overloaded and confused. So let's get into some examples, and we'll just start doing some mathy stuff. Is that cool? I hope so. So here we have our first example. We're going to find the surface area in terms of pi. So here comes that word again, in terms of pi. What does that mean? Okay, so that means what we're going to do is treat pi like it was like an x, like a variable. Okay, so we're going to treat pi like an x. We're not going to get, we're not going to think 3.14. Just like we talked about in the cylinders, you got to ignore that 3.14 thing. We're going to treat pi just like an x. Okay. So we're looking for surface area, and how is it that we find surface area of a cone? The surface area of a cone is equal to the lateral area plus the area of the base. And so we're going to need lateral area and the area of the base. Hopefully you see that the area of the base is pretty doable, and we'll get to that in a second. But we need to find our lateral area first, okay? And lateral area, just like we discussed in the previous slide, is 1/2 the perimeter of the base times the slant height. Okay, so our slant height is given, is 25 centimeters. So that's really fortunate that that is so convenient. So the slant height is 25 centimeters. How do we find then the perimeter of the base? In the base, we're given a radius. Okay, so 15 centimeters is our radius. So for the perimeter of the base, circumference of the base, we want to use radius because it's nice and convenient. So the perimeter of the base is 2 pi r, or in this case, 2 pi times 15. And so the perimeter of the base would be 30 pi. Remember, we are treating pi like a variable. Okay? So we have our perimeter of the base, 30 pi centimeters squared. We have our slant height, 25 centimeters. And so we have our, perimeter is not squared units. Whoa, that was close. So the perimeter is 30 pi centimeters. The slant height is 25 centimeters. All we have to do to find lateral area is take half of that product. Okay, so we're going to have lateral area being equal to 1/2 times the perimeter of the base we found at 30 pi times the slant height that was given at 25 centimeters. Okay, so the rest is calculator work. Remember, we're treating pi like a variable, so we're not going to call that 3.14 because it's not 3.14, but we'll do 30 times 25, whatever that equals, then divide that by 2, and then we have 375. So the lateral area is 375 pi centimeters squared. That's our lateral area. The question, however, is calling for surface area. So what we have to do is take that lateral area we just found and add it to the area of the base. So now what we have to do is find the area of the base, and we all know the area of a circle is pi r squared. Remember, that has not changed. The area of the circle is still pi r squared. Okay, that's a standard formula everyone should know. Excuse me. So in this case, we have our area of the base. Remember, the 15 centimeters is our r. So we have pi times 15 squared is going to be the area of our base. 15 squared is 225. So the area of the base is 225 centimeters squared. Now, here's an interesting question. Are we sure that we can add these two values together? And there are two things we want to look out for. Thing number one, pi. Now, they both have pi, so that's kind of helpful, right? That's convenient. So, yay. But on the other hand, can we add them together because of their units of measure? Now, we can add these both together because they're both centimeters squared. It's a helpful thing to keep in mind. So just because they're both numbers doesn't mean we can up and add them. We want to make sure that we're working in the same unit of measurement. So anyway, the surface area would be the lateral area, which we found as 375 pi, plus the area of the base, which we found at 225 pi. So all we have to do is add that together, and we have something that sounds absolutely delicious, 600 pi's. So our surface area is going to be 600 pi centimeters squared. That's how that works for the surface area and lateral area of cones. Okay, so let's do another example. This is going to be interesting because we'll think about where we can apply this. So here's like chemistry, right? In a lab experiment, you use the conical filter funnel shown at the right. How much filter paper do you need to line the funnel? This is such an interesting question. We have to know what it's asking. How much filter paper do you need to line the funnel? So what is it asking for? Is it asking for surface area or lateral area? Okay, so this is a huge question that you have to be able to understand. The filter paper is only the way around, so the filter paper is only asking for lateral area. So we don't need the surface area here. We simply need lateral area. And how is it that we find lateral area? Again, 1/2 the perimeter of the base times the slant height. Okay, so that's how we find lateral area. Now we look at our diagram and the information given, this is not giving us much. So now what we have to do is start uncovering stuff. Okay, so this 45 millimeters is not the slant height. We have to make sure we understand that. And the 80 millimeters, of course, that is our diameter, so that is helpful for perimeter. So we need to find our slant height. That's what's missing is our slant height. So let's first start with perimeter. Can we find perimeter? And remember, perimeter is either 2 pi times the radius or pi times the diameter. So that makes life easy because the perimeter of the base, if 80 millimeters is our diameter, the perimeter of the base, oh, that's really doable. It's 80 pi millimeters. That's the perimeter of the base. All we're missing now is slant height. So how do we find slant height? Here's the dealio. We have a pop-out triangle, do we not? Yes, we do. And in that pop-out triangle, what we're missing is the hypotenuse. That's the slant height. What are we given in that pop-out triangle? Well, we have 45 millimeters from vertex down to the right angle. So this is our 45 millimeters. And the other leg, well, that's going to be interesting. The other leg is 1/2 of 80. Okay, so this is our half side. 1/2 of 80 is 40. Okay, so we can now find our slant height. Now, how is this going to work? Very similar to a previous video. You got to be careful of what's happening here. This is where Pythagoras comes into play. Remember, Pythagoras has taught us all that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. We're going to apply that theorem here, but we're going to be very careful with numbers. The slant height is our hypotenuse, so our legs are 45 and 40. It is the slant height that we're looking for. So how do we find the slant height here? Remember, the whole thing is that we round at the end. What we're going to do is take the square root of both sides. Okay, so our slant height is going to be equal to the square root of 45 squared plus 40 squared. Okay, and we're going to leave it like that because we round at the end. Okay, so remember, we leave this because we round at the end. There's a few roundings that are going to take place here. Okay, so this is our slant height. We have our perimeter, we have our slant height, and now we are ready for formula. So we go back to the lateral area formula. The lateral area is 1/2 times the perimeter of the base, which we found at 80 pi, times the slant height, which we found as the square root of 45 squared plus 40 squared, and we will crunch all those numbers, and then we will find our lateral area. Now, how's this going to work? Okay, so just like before, because this is the craziest thing that's happening, we're going to begin with that operation. So we'll have 45 squared plus 40 squared, whatever that equals, and then we take the square root of it. Okay, look at that crazy, crazy number. That's this value here. We're going to multiply that by 80, and then multiply that by pi. Okay, so there's a pi button on the calculator that makes life easy, whatever that equals, and then we're going to take half of that. So divide all that by 2, and then we have our, did I hit divide by? Because that number doesn't look familiar. I'm going to do this again, because, oh, maybe that is the right number. It is familiar. Okay, so all of that value turns out to be 7,565.957 millimeters squared. That's the lateral area. Now the rest, it depends on what the question is asking for. Is it asking for, to the nearest square millimeter, to the nearest thing? So it could be 7,565.96 millimeters squared. It could be 7,565.60 actually millimeters squared. So or just 7,566 millimeters squared. So what we want to do is round at the very end, and that was the bell for my second period class. So anyway, that's how surface area and lateral area works for cones. So sometimes our slant height is missing, which means trigonometry comes back, right? Just like we did in the pyramid activity. And here are a couple other questions. I'm not going to go over them right now, but just to view them. Radius of the base is 16 millimeters. Slant height 28. Surface area, piece of cake. You're given slant height. You're given radius of the base. You're fine. Lateral area of a traffic cone. Radius is 10. Height of 28. So we have to find slant height. Okay, so the slant height would be equal to, the radius is 10, and the height is 28. And so we would use Pythagoras there as well. Okay, so we got to be careful with that. And that is it for the surface area of cones. And that is it actually for the entire unit. So we are all set for the unit on surface area, and we'll catch you on the next unit.